Okay, so good evening to all of you. My name is Michał Kwieciński and with me is Kasia Chełmińska. We are both employees of PwC here in Poland, and we represent the data analytics and geodata analytics teams, and we wanted to tell you a few words today about processing spatial data with Python. But before we start that, I just wanted to use 5 minutes to tell you a little bit of what do I do, what does Kasia do, and what does Marcin and all our friends at PwC Data Analytics team, what do we do in general. And PwC, as you may already know, is a worldwide consulting and assurance and tax advisory company. So we actually do a lot of different projects in different areas, and data analytics is just part of many things that we do. But we think that at least here in Poland and in few other territories we excel regionally in data analytics, and this is why we have built a data analytics center of excellence for Central and Eastern Europe, and there is at least 20 data scientists of us here in Warsaw, and another 10 developers that are using mostly C# and .NET as their technology stack. And there are also a few people in Prague, and there are another 4 people that are working strictly with spatial data, and Kasia is one of these people. And we are working mostly with clients from financial sector, retail sector, logistics, and some maybe 20% of our work is just ad hoc. Depends on what client, what our client needs are at this particular moment. Problems that we solve are, I would say, various. This is probably sorted from most common to least common, and so we are analyzing campaign effectiveness, pricing, promotion. Pricing, this includes some real-time implementation of pricing, and churn management, estimation of client lifetime value, assessment of bank branches, assessment of retail networks, so where to position a shop or bank to be most profitable. We are redesigning supply chains, optimizing logistics with simulation tools. We are performing risk analytics for banks, and this is how actually we have, this is the area we have grown from. We have a lot of experience in that area. We've been having recently projects that require developing big data architecture for a few banks, and in terms of management information, we are providing our clients with some visualizations based on, for example, Tableau, and this is to serve the management reporting. Those on the right, like analytics, inventory optimization, fraud analytics, predictive maintenance, recommendation engines, and workforce diagnostics, all those things are our forthcoming projects that are either in pipeline or in research and development phase. But if you decide to join us and we are hiring, you will probably be able to learn one of those things along with us. And as I said, we are looking mostly for data scientists and C# developers on different levels, both for internship and for higher grades. We are looking for people who are able to think. This is probably the very basic and main requirement, but also with a degree in maths or statistic-related things. So they should be able to do all those machine learning algorithms, and they have to be proficient in either R or Python, and plus SQL. This is the very basic thing, and among other things, we want them to get ready to be challenged with learning new things. If they come with some knowledge that can be spread between all those 20 and maybe even more in the nearest future people, we want them to teach us about new things they know that we don't know. We want to. Each of us come from different environment, with different background. So we share on projects experience one with another, and I think this is great environment for learning very fast from 20 different people with different backgrounds, ideas, knowledge. So okay, that would be all about PwC in general. So I invite you to recruit online through our website, and so right now we can move to the core topic of our today's presentations, which is analyzing spatial data. And first of all, what do we mean by spatial data? Because well, it's really obvious. It's just that where you can look around you for entities like objects, like people, like vehicles, like places. So right now we are here at some latitude and longitude. All of you are living somewhere, you have addresses, you work somewhere and your work has some address. You are moving around town, so wherever you go, you are somewhere in this latitude and longitude space, and all this can be recorded. It is recorded actually, and there are some companies that you will know that analyze this data. And our clients have, like I said previously, bank branches, retail stores. They are somewhere in the vast space, and they have some address, and this can be analyzed. There are many other things that can be put on a map with latitude and longitude. So when I said entities, there are some companies that analyze animal behavior, and this can also be tracked and put on a map. And probably some of you come from background with such company, or you do such analysis on university or somewhere else, I don't know. But the spatial data is everywhere around us, literally, and I think that it is not that common that when people do machine learning models that, I don't know, predict, let's say, price, or do like you said previously about the face recognition, and you said that there are people that come from different that can be Japanese, they can be Chinese, and they have different faces, or they can talk differently. And I know within China you have different regions with different the people talk differently in different regions, so probably you can actually here apply some spatial data on aggregate level, and as a feature to a model that determines how do people talk. So this is just one example of when you can enhance your typical data with some geospatial features. Not only latitude and longitude, and what do I mean by that? We'll Kasia explain you in just a minute. As I introduced Kasia from the team of geoanalysts, I am a team of data scientists, and with help of other industry experts here in PwC, we try to combine all those three things to get the best models possible. So the models that use spatial data and that get interpreted by our industry experts that are beneficial to and delivering value to our clients. This is what we mean by business geoanalytics within PwC.
Okay, now I would like to show you types of spatial data which we used in our methodology. As you see, there is 4 types. This is points for exams, banks, schools, shops. Next is the polylines, which can be represented by roads or rivers. the polygons, which can be represented by admin borders on the land cover, and rasters, which are grid cells with gradual changing data such as, for example, population density or purchasing power per capita. Here we listed for you the mostly used type of geoprocessing which we use. First of all of data we have to geocode and put it into a specific coordinate system. And if you want to do it, you have to know it is quite difficult because there is a lot of kind of projection and coordinate systems. So, and each of them have specific EPSG code, and you have to know it, all of them. In each our analysis, we create also drive time or radius catchment for determination scope and potential the nearest neighborhood, for example branch neighborhood. Then we intersect data. It means, for example, we have drive catchments and some points, for example schools. When we intersect this data, we have a list of schools in catchment areas with all attributes from both these layers. Then when we need counting something by spatial distribution, we use spatial aggregating. Then we, what is more, we always in our analysis calculate distance between points, polygons, or polylines. For example, we calculate distance from our client's branch to their competitors. This is general, but at the end we create thematic maps and heat maps, which is results of our spatial models. We work with two GIS software. This is ArcGIS and Quantum GIS. Do you know it? No. So it is for creating and using maps, compiling geographic data, analyzing mapped information, sharing and discovering geographic information, using maps and geographic information in range of application, and managing geographic information in a database. And how they differ. First of all, ArcGIS is commercial software created by S3, and QGIS is free and open source. Duedu ArcGIS is commercial software. It's used by government and commercial agencies like PwC, PwC, and it is better documented because of that. However, QGIS is also popular GIS software for academic or non-commercial users. It works better and quite faster than ArcGIS because it uses 64 bits where ArcGIS only 32 bits. However, both QGIS and ArcGIS can be extended through Python scripting and plugins, and Michał tell you about it.
Okay, so we promised it would be about Python, so at least part will be about Python. And as Kasia said, there are some extensions to those tools that allow you just to point and click. Many of those features that you have on a map, like you said, points, polygons, rasters, etc. There are some things that can be easily done just by hand or clicked in some menus, but there are things that you would like to automate, and you can automate very fast if you are a proficient Python or ArcGIS or QuantumGIS user. This can be done with one of two extensions that come with those two software programs, and this would be ArcPy extension. That is the part of ArcGIS, and this is PyQGIS, which is part of QuantumGIS. And again, one is commercial, one is open source, but if you are processing a lot of geospatial data, at some point you will probably want to invest in ArcGIS, and this is very intuitive for ArcGIS users like Kasia is. Probably the PyQGIS is a little bit less intuitive. It's a little bit less documented, and it has not that much features. There are only some, maybe not really basic and extendable geospatial processing tools, but what is implemented in ArcPy are almost all features of ArcGIS, and ArcGIS is really powerful tool, and this is why probably it's paid in this open source processing. There is no single open source processing tool that would be as powerful as ArcGIS, and this is probably one of the reasons why you would like to use ArcGIS and ArcPy. And how can you use it? The usual scheme would be to open a console that is built into either ArcGIS or QuantumGIS, and just start coding from inside the console. We'll also show you a few examples later on. And ArcGIS or ArcPy within ArcGIS is, as I said, accessible from console. It works with Python 2.7 code. This is an external library. It's not that easy to connect it in separate IDE, but it's possible. So you can use it in PyCharm or whatever you are using. But again, it requires you to have ArcGIS installation with active license, because it is paid software. It is possible to use some Python code within other places of either ArcGIS or QuantumGIS, like there are special fields for calculations. There are special fields for making your user-defined functions and using it for just point and click within both of those tools. And as I said previously, ArcPy is extended with several modules. This is data access module, so it is for reading a lot of types of geographical data. Probably I couldn't even count how many different representations of spatial data there could be, with most common like shape files, which are S3 shape files. But they are right now it is very common to write it in JSON. It is common to write it in XML, and KML is I think the main format for example, for Google Maps. So, but there are like hundreds of others. rasters can be like TIFFs or can be just anything like ASCII binary files. And all of those formats should be read, and there is a data access module that deals with it. Then there are modules for mapping, so actually it's more visualizing than actually processing the data. But for processing is geostatistical analysis module, which is for vector data, correct me if I'm wrong, and ArcGIS spatial analysis extension module is for raster data. Both of those tools have powerful libraries for all things like spatial aggregating, intersections, all those typical geo-analyst basic and non-basic functions he applies on his usual day's work. And finally, there's ArcGIS Network Analyst extension. There are some alternatives, freeware alternatives to that, but in this case, you can very easily start processing algorithms like routing algorithm, determining optimal locations with help of within networks like road networks, which can be represented as graphs, and which are very common layer that is a very common layer of spatial data. So as I said, in quantum GIS, it looks very similar. You can you have access to loaded layers, so you can open quantum GIS and open the console. And before you open the console, you can just point and click and load some shapefiles, some data, some attributes, and only then from within the console do some write your own functions that would automate things that you don't want to do just pointing and clicking for like thousands of millions of times, because there are because you would like to, for example, get to distinct shape files of countries that you have downloaded from two different sources, and you would just snap those two shape files to one to another, and you would have to probably do that by hand, point by point, and there are millions of points that make a borderline, and you can do it just by a few lines with code in a console, and then you can go back to pointing and clicking, because this is probably easier way to do than coding in Python. And okay, so I said about ArcPy, I said about PyQGIS, and but I think that what most geostatistical analysts would do when faced like for other problems, or people that would not be proficient in ArcGIS or quantum GIS, they would use tools that have very neat APIs provided by Python. So there are multiple Python libraries that help you deal with spatial data, and the first library that is available, that is openly available within PyPy, and this is GDAL, and GDAL is actually a library of GDAL, whatever you pronounce it. So GDAL or OGR are a set of libraries, C++ libraries actually, that provide you access to all those different kinds of data that I mentioned previously, the different spatial libraries, and this is actually the very basic tool that is probably implemented either inside Quantum GIS or even inside ArcGIS. So those GDAL libraries are basic tool for any geoanalysts. And what you can find here is that it's actually, because as I said, it's C++ library, so GDAL is only an API to this library. But because most of geoanalysts work with Python, not directly with C++, so it's very common to use GDAL library within Python. And there are other tools that extend the possibilities that come with GDAL. This is, for example, Fiona. This is another wrapper, very easier to use wrapper than GDAL around OGR, where GDAL is for raster data, then OGR is for vector data. This is the split that was historically. Right now it's almost the same. So Fiona is a very easy wrapper. So if you want to manipulate data, small data fast, so like prototyping, this is very good way to start. If you want to massively process data with Fiona, you will probably have to write it with some other package because Fiona tends to be very slow. Another package which is a little bit better is Shapely. So there are some advanced processing tools, like again intersecting data, like convex tools, things like that. But this is another wrapper around another C++ library, which is called GEOS. So I will tell you what does it mean. This is a wrapper around C++ library in just a minute. Another library very commonly used is GeoPandas. Actually, it's I think quite a new library. So it is kind of extension, and it requires normal Pandas library. It's an extension to Pandas data frames where you can put additional columns with spatial data and process those columns with functions from, for example, Shapely or Fiona. So when I said previously about the network assessment, like routing algorithm within ArcPy, for the free alternative is probably right now the NetworkX. This is a library for network analysis. This is actually something that you can, where you can implement graphs that do not really relate to geospatial analytics, but one of the possibilities is that you can represent routes with graphs within this NetworkX, and this is another great tool to use. Some spatial statistics. This is how actually I have begun working 5 years ago with geospatial data, not in PySal library, but it was in R. But what PySal probably does, from what I can expect, some are functions like econometric models for spatial lag, spatial dependence models, and like some moral statistics, things like that. So there are also packages for kriging, which is very popular interpolation technique, and this package is called PyKriging, very obvious name, and this is probably another tool that you will want to use if you have some raster data or just point data and want to interpolate it to make it a raster data. And there are many others, other tools. I think there are 100 libraries within PyPy, and you can check it on your own. They are cataloged, and you can check on your own. And depending on your needs, you can assess what tool do you need. There are some performance issues, and very important thing when you do spatial joins, which is one of the most basic things that you would want to do with your data, is to use spatial indexes, and not every tool actually supports that by nature, so you would want to extend your libraries with other libraries like R3 or the spatial index. This is a common extension to GeoPandas, for example, and there are some spatial indexes that are actually embedded in ArcPy, and they use the S3 spatial indexes. You would like to research various libraries. I mentioned on the previous slide several libraries. They are probably somewhere a good place to start. There are many others, and you would like to research on your own. You would like to verify whether those libraries support parallel processing, because those those libraries like GDAL or GEOS, they are C++ functions, and currently they are not parallelizable. So if you want to process massive data, you are stuck with one core. And I think it will change very soon from what I have read, but it's still under development, so it's a problem. Okay, in ArcPy, if you happen to work in ArcPy, just make sure that if it's sensible to do that, try working in memory, not read and write every spatial object to the disk, because with bigger data sets, even if you have enough space, it will take some time to read and write this. And finally, research outside Python, and this is what actually is the next slide about, because what we tend to do typically is process data more or less manually with this point and click in ArcGIS. Then we are using a lot of Microsoft SQL Server just to store our data for different courses, and because we want to store it in just one place. And SQL Server comes with some basic geospatial processing functions. Then it's also a tool of choice for us. And only then, if we cannot meet our needs with those two tools, we want to process something fast, then we reach for Python. So and those three things are not really the only things that exist in GIS technology stack. For example, one would prefer things like PostgreSQL or PostGIS. This is an extension to PostgreSQL, where you can store spatial data, and we tried it once just because there are other extensions that help process this data. But again, I think the PostGIS is not parallelizable, whereas operations in the SQL Server and those spatial functions are parallelized, and this is why we would like to store some data in SQL Server and process over there, not move it to Python, or not do it in ArcGIS. So our advice is, if you are very new to geospatial data, is to start slowly with those tools like ArcGIS or QuantumGIS, where you can just try on your own with your hand and just with your eyes. You can try what is a point, what is a vector, what is a polygon, what is a raster, and only then when you get to know how to do some basic operations just by clicking, only then we suggest that you move to operating on those objects within Python environment, when you are not able just to instantly display it on a map and show you the result instantly of what function you have just made on the data. Ability to visualize maps is something great. We like it very much. Our clients like it very much because the end product is very colorful map, and this ability to visualize also helps you to develop your code, even in Python better. So another thing about not using Python, which is the most popular backend for GIS processing anyway, is that this is an example where you can use the C++ library, this GDAL library, within console just in one line, whereas you would have to write 7 lines to get the same operation in GDAL in Python GDAL library. So sometimes there is a lot of overhead to the things that you can do in just one line. If you are an expert and you know what you're doing. The middle example is actually opening the console from within Python, and this is something in yes. If you are working with heavier data sets, and this happens sometimes, actually it happens for us on the ones that we had really problem with processing data in any other way. Like we had 5 million addresses, we had to geocode that information, and then we have also been provided with 160 million points. Those were duplicates mostly of those addresses. So again, but we had 160 million coordinates, and we had to do some clustering over these coordinates. I don't want to tell you what the business problem was behind it, and actually it's still an ongoing project, so I really cannot tell you details about business IT. But so to do this, to the clustering, so not a lot of clustering, just the dimensions. But we have actually moved this data to a Spark instance, and within Spark we did this basic clustering. So we got 2 million clusters. So every cluster, you can estimate, consisted from some 80 points on average. There were bigger clusters, smaller clusters. There was some analysis of outliers, etc., etc. And this is how we utilized Spark. It wasn't a lot of data for Spark, but still, it was the easiest option to do with what we could. And there are no good tools for processing massive data, massive geospatial data on Spark right now, I think, especially in terms of this analysis of networks. Because what we wanted to do with those 2 million clusters, we wanted to get back to another 2 million addresses and make 2 million routes between those addresses, and get 2 million vectors, actually polylines that connected those 2 points. And there is no tool. We couldn't find those tools that could do this for us, so we waited for days to make it just on our server and just within the ArcGIS environment, and of course using Python, because we were asking just each pair of points to process it within ArcPy, and getting back the results and mapping it and doing some spatial joins on this data. But still, I think there is a lot can be done with this spatial processing, especially on Spark, and especially in Python. There are some names of things that we have Googled for you, like S3GIS tools for Hadoop, but this is Java, not Python. There is a Python API for something called Magellan. This is for Spark, but there was no routing option, and there were no routing algorithm in there. We didn't try to write our own, because you would have to put entire network, and network was also in shapefiles. It took us 4 days to do it the way we already knew how to do it, and we'll probably spend another 2 weeks in thinking how to get the entire map of Poland and put it into this Spark, debug all things that would come somewhere on our way, and it was just easier to do. But probably it's possible to use, for example, Spark GraphX, yes, a library, and to do some Dijkstra or A-star algorithm over there, and get the same results, maybe not in 4 days but 2 weeks, and with some stable version. There's Spatial Spark, and but again, it will probably be much more common than Magellan. I think it's still under development. There are spatial joins, which is very important because either in S3 tools for Hadoop and in Magellan there are no spatial joins, and with so much data, spatial joins are really a requirement. And there are tools that I haven't even only heard about it, are GeoSpark or GeoMesa and GeoWave, that are some geospatial libraries over Apache Accumulo, but you can research it on your own. I'm just giving you some names. So to finalize, just two simple examples of what can be done. So okay. So right now we are at what is the address in here? It's Aleje Jerozolimskie 181. So we have checked latitude and longitude for this place, and it turns out that when you put these coordinates in some different projections, and there are 100,000 different projections that geoanalysts should know, you don't put latitude and longitude in the usual decimal format. It's some different format, so it's another hurdle for geospatial analysts to know all those stuff. But still, you open your IDE, you import ArcPy, you import data of Warsaw in this case. You create your own point, which is set with those two latitude and longitude with this 21880 projection. And so as you can see, there are many lines of code to just get import something and make a new point. But when you have a lot of points, you can automate it in the similar ways, number of lines. So it's not the usual case for Python, but just showing you that what can be done within the console. And the next point is that you load, for example, downloaded from OpenStreetMap the bus stops in Warsaw, and then you do select layer by location, which is actually telling that you want to find within 500 meters distance from Centrum Szkoleniowe Adger, the location defined previously, all the points that are on this layer of bus tram stops, and the result can be selected, and the result are only those points that are within 500 meters radius, and you can save it to another layer, and you can just print a count of how many points is in this layer. So the second example, not with code but maybe more inspirational, would be the fact that okay, we have a model that was based on geospatial data, and so it's not real example in terms of we have actually done that, but the business problem that it's not what was actually in reality. So we build a model that predicts number of Python users in proximity, for example, of proximity of where we are right now, based on random sampling points. I don't know how we collected this data, maybe service, maybe some online tracking, maybe some other, it doesn't really matter. Then we actually make a grid in entire Poland of points that are separated by 100 meters distance, and so there you can calculate it as 100 points in 1 square kilometers. There are 312 square kilometers in Poland, so it's a lot of points. But then you can crop it just with like administrative borders, shapefile of administrative borders of cities in Poland, so you have a lot of less points, probably some 15% of that, maybe 20, and then for each of those points on this grid, you calculate the statistics that you have calculated for your model, and then you can then you can make scoring in all those features, and then you can, before exporting to KML, you have to probably make some interpolation, and then you can export it to KML. All of these steps can be done in Python and should be done in Python, and were actually done in Python. And then you can visualize it in Google Maps. So, for example, this is a scoring of Warsaw, and this is actually where we are right now. So, if our model was to select where Python users are, probably it failed. But we are probably more around Plac Zbawiciela right now. But this is how you can visualize the final input from your machine learning models that utilize spatial data. So I think that would be all. Just the concluding remarks, I think, are that we want to be here as like an evangelist of using spatial data within machine learning applications. I personally feel that not many people use the spatial data where they can look for those spatial features within data sets of people or any other objects that are in their machine learning models. And so probably I hope that today it will be a good start for some of you to research this field, and to think, at least when you will be developing new features for your next model, to think, okay, can I attach some spatial data? This doesn't have to be latitude and longitude. This can be, for start, this can be downloaded data for how many people are in the city that somebody lives, or the business is, and this is a very good way to start. So look for new features, and look for those features in the space around you. Yes.
Okay. We have questions. Sorry.
Because we are data addicted, so tell us about something interesting or funnest what you learned from your spatial data. And second question is maybe can you tell us about some selected project what you performed?
Okay, so this is an example of actual project. I didn't name it, but this was actually scoring some sales network. I will not tell you what they were selling, but the entire project was to just build a predictive model to determine where the sales will be the highest. And in our work it's not the end, because you have non-deterministic sales, and this is where our model excels. But then you have also costs, and so finally where the highest margin will be, you can only tell when you also apply some cost estimation, which is not a stochastic model. It's just an assumptions given by our experts, and this is where those two things combine. So we as data scientists match with our industry experts and provide some business cases for network expansion. so this is an example. Could you please repeat the first question?
What is the funnest or most interesting thing do you learn from spatial data?
Okay.
Because fun.
Okay, so actually it will not be encouraging, but I think the most interesting thing is that there are many spatial features that don't always work as you expect, and they don't give the predictive power that you would expect to your model. They give predictive power, but they are not as significant as you would expect at the beginning.
Okay, any more questions? Who was using spatial data before?
Some spatial.
Okay, a few people. So maybe you can tell us where to start with spatial data.
I think think I've said it at some point that I would encourage you to start with just manually going around like tool like QuantumGIS, and so download some shapes, download some points. For example, I don't know, like airports in the world data set, and try to, I don't know, count how many airports are in each country in the world. This is probably some basic geospatial operation that you can do, and learn at first within this friendly graphical user interface environment that is provided by QuantumGIS, and then move to, if you really have to, then move to some other tools, just depending on your needs.
Okay, so I think.
Do you work mainly with clients' data that you can't, for example, save, or do you have some kind of accumulation of knowledge, and so this special data can be later reused for further classifications or regressions?
What we cannot do is take. We work with many different companies, and often they are competitors. So what we cannot do is take data from one company and then go to the next company and tell them that, okay, we have data of your competitor, we can build model based on your data and your competitor's data, so you will be better off because you came second, not first. So this is what we cannot do. So we cannot enhance one model with data from the other model, but we have some prior knowledge, and right now it's expertise. If you do second and third project, you know what hypothesis can be, so you work faster. You know what hypothesis will probably work and which won't work. Spatial hypothesis especially. So, for example, we don't use anymore the number of pharmacies in the radius of 100 meters. This feature is not interpretable in terms of some models, and it doesn't ever work. So.
But do you work with customers' data, or you buy them? When you start a project, you go to the customer, okay, data, or?
Okay, we have a lot of data that is either crawled from the internet if it's freely available. So we actually maintain a set of C# crawlers that crawl data from sites, for example, that list addresses of some networks. We buy data either for Poland or for another country if we tend to do project in another country. We have recently bought another map of routes in Poland because those freely available, for example, on OpenStreetMap, they are okay, just fine probably for visualizations, but if you want to calculate routes, you have to make sure the data is high quality, so we actually bought it. And there are some data sets that you just need to download, and you can download just by browsing through the internet if it's required.
Okay, so basically you can go online and find something,
yes, exactly.
Just to playing with.
Well, most of our customers don't have their own data, so this is where we add value. So we have our own database with a lot of geospatial data, and this is and we use them depending on the project need.
Okay, thank you. Okay, thank you so much for your talk. So right now we're moving to Świeżonowane, which is next door, for the after party. You want to play speed dating before?